And share screen. Let's get started. Okay. 3-bromo pentane can undergo either an SN2 or E2 reaction with HO minus hydroxide. All right, so the first question, is the substrate primary, secondary, or tertiary alkyl halide? And part B is give the product of each reaction. So go ahead and work on that for about a minute. Come up with your answers, and then we'll go through it and we'll walk through to make sure you're getting the right things. I'll sit here quietly and stare off at my phone. So just as a reminder, that first question should take you 2 seconds. The second one probably should only take you 10. In a perfect world. I'm not saying that that's where you need to be, but in a perfect world. Give me another half minute. Okay. So looking at this, is this a primary, secondary, or tertiary, Meg?
Secondary.
Yep, it should be a tertiary because this carbon here, right, is connected to 2 carbons, therefore it should be secondary. You can give the product of each reaction. So in an SN2, we simply substitute. Do I have to worry about stereochemistry right now? No, because the question you always ask yourself, remember, is it a stereocenter to begin with? If it's not, don't worry about it. Just simply replace with straight line. So it's simply going to be this. Now, with our next one, when we do E2, normally you should ask yourself, is it a bulky base or is it a small base? But it's the same thing on either side. So you don't have to worry about that question. If each beta carbon is the same, then you don't have to worry about it. You have an ethyl to the left, ethyl to the right, no difference. So it doesn't matter which one you take. Your double bond should be here. And if you happen to draw it the other way, it would just be on that side. So it doesn't matter which side of it your double bond's on, it's going to give you the same product. Make
Doesn't
sense?
matter. Doesn't matter if you like draw the line like underneath instead of
No,
like
it's the same thing.
Okay.
Yeah, it's just how you draw it. So the way that I was always taught to draw it, and it doesn't matter if you do this or not, is just always draw your straight line chain. And it doesn't matter really, just as long as you start at one corner like that, and you're kind of inside of the angle. So if you were to do this, this would be fine too. It doesn't really matter, just as long as you can clearly see that that's double bond. Okay, any questions on that? Okay, so then part C for this is, it says, when the reaction is heated, the major product has an IHD. And what does IHD stand for, or what does it mean?
Degrees of saturation.
Yep, this is the index of hydrogen D something. I forget what it is because no one uses it. So Morgan, I don't think you were here yesterday, but IHD is the same as degrees of unsaturation. So if you remember, for every one of those, that's a double bond or a ring. So if we think back to our reaction that we just did, knowing that information, which product did we get? The E2 or the SN2?
The E2.
The E2, right? Because it means you have a double bond. And also, the other way to check this is that you do not have an alcohol at like 3,400, that giant alcohol peak, right? So there's three things in this question that tell you that it is going to be an E2. We just went over two of them. The degrees of unsaturation or IHD is 1, so there has to be a double bond. The E2 product always gives you a double bond. The IR spectrum is missing this OH peak that you would see in the SN2. And what other thing is in that sentence that tells you that the E2 is favored?
Heated.
Yep. Heat. When you heat a reaction, you favor the elimination, Morgan. So just if you remember. Good job, guys. You guys are sounding a lot better today than you did yesterday. You sound a lot more confident.
Yeah, yesterday I was just, yeah, I was not in it yesterday, but today I feel a lot better.
It's good. Practice, practice, practice. Okay. The following E2 reaction can form 3 different alkenes that are constitutional isomers. Draw all 3 constitutional isomers and rank most stable most stable to least stable using Zaitsev's rule. So go ahead and draw all 3 products. I will give you guys a moment. Give you another 30 seconds. So, Gwen, what's Zaitsev rule while you're working on your answers?
I don't know I don't know the definition.
If you had to use your own words, then
The most, or I don't know, like it's normally the major product, I guess, of a reaction.
what type of reaction?
Elimination reaction.
When we talk about Zaitsev and Hoffman, we're usually talking about E2. So, as a reminder, while you guys are filling this out, Zaitsev and Hoffman were both scientists working in the late 1800s on the elimination reaction. Zaitsev discovered the E2, but he did it with small bases like methoxide and hydroxide. And Zaitsev found that when he did his reactions with very small bases, the proton would be taken from the most substituted carbon or the carbon with the lowest number of hydrogens. Same thing. Hoffman, at the same time, doing work in Germany as opposed to Russia, discovered that he was doing the same type of reactions, except he was using big bases like potassium terbutoxide. The only thing is that he found when he used those big bulky bases, they went for the least substituted carbon or for the carbon with the most amount of hydrogens. And so that's the difference between Zaitsev and Hoffman. So if you have something like hydroxide, amide, methoxide, ethoxide, you're always going to take from the carbon with the least amount of hydrogens. If you have something bulky that has like propyl or isopropyl or tert-butyl in the name, then it's going to take from the least substituted. But in this case, let's go ahead and look through it. So first thing that I want to do is in this type of problem, if this is you guys on test tape, locate your alpha carbon, your carbon with your leaving group. Immediately then, find every beta carbon. That means every carbon that is touching. So if you want to make sure that you do this correct, just go through each of those carbons that you have circled and say what they are. Primary, secondary, tertiary. So in a Zaitsev product, what is going to be the favored one? Which carbon do I want to take a proton from? Primary, secondary, tertiary, according to Zaitsev. the highest order substitution, the one that is attached to the most carbons or the one that's attached to the least hydrogens. That's essentially the same thing. So which one is that going to be? Primary, secondary, tertiary? Tertiary. Zaitsev is you're always going to take it from the highest order. So from the tertiary, then the secondary, then the primary. So my product one, this will be my most stable one, is going to be when I take the proton from this carbon, and then I am going to form this double bond like that. My next most stable one is going to be when I take the proton from the secondary. I'm kind of just drawing this best I can because it's a little like that. And then finally, my least stable product is going to be when I take it from the primary. So just to help you guys out with a little bit of color coding, because color coding does help. As I said before, I recommend colored pencils when you're learning things because they make life just a little bit easier. Like that. Does that make sense? Okay. If you have the option of making a cis double bond or trans double bond, Mags, which one is more stable?
Trans.
Yep. If you can make a trans double bond and a cis, the trans will always be the more stable one. Questions from you, Morgan or Gwen?
No, I'm good.
Okay, cool. Can I erase this?
Yeah.
Cool, cool, cool. All right, question 3, predict the major organic product for the following SN1 reaction. So what's the best part about them telling you that it's an SN1?
You don't have to,
You don't have to figure it out.
You don't have to sit there and figure it out. This is really the best type of problem you're going to get, right? Is that you don't have to worry about it. But let us work through the first one together and let's just go through our little checklist, right? So normally when we're going through a problem and we have to figure out SN1, E1, SN2, E2, what's the first thing you look at?
the type of carbon.
Yep, you find your carbon with your leaving group, right? And in this case, it's a tertiary. I already know it's an SN1, but this is what you would normally do, right?
Mhm.
Now, the next thing you want to do is it a stereocenter? So Morgan, is this a stereocenter?
I honestly don't know.
Are there 4 different things attached to that carbon?
Yeah.
Check again. Or is there a plane of symmetry? So the way to think about this is you have this bromine, right? That's one thing. You have a methyl, that's something different. But then you have a CH2 to a CH2, CH2 to a CH2, which meets here, right in the middle. So is that a stereocenter?
No.
No. So then, since it's not a stereocenter, how many products are you going to get?
Just the one.
Just the one. If it's an SN1 and it's not a stereocenter, you get 1 product. If it's SN1 and it is a stereocenter, how many products do you get? 2.
2.
Mm-hmm. So for this one, your answer should just be draw your 5-membered ring, hopefully a little bit better. And you're just going to replace your bromine with the iodine. And this should be your answer for that one. Does that make sense? So in this case, we kind of can eliminate that first step. But the next thing you always still want to do is make sure that check to see if it's a stereocenter and then go from there. All right, so I'm going to clear this and I'm going to scroll down. And now work on the next 2 and see what answers you get. I'll give you a minute or 2. And I'll pause the recording so they don't have to just sit here and watch. Now, for those people that are watching at home, I'm sorry I skipped over the answers for the last one. I will draw them real quick while they're working on these last 2. Your answers for the last one, and I'm going to scroll up again and draw them. I forgot to do that so you guys can keep looking. Is that you're going to have a rearrangement in both of these. So in this one, your product is going to be this because you are going to have a rearrangement. And then your product for the bottom one we're also going to have a rearrangement. And it is going to be this, because both of them, when they pop off, are secondary carbons next to tertiary. You have a hydride shift. You then add your nucleophile. Okay, so let's look here. So we know that these are going to be SN1s again, so we don't have to worry about that nonsense. But is this a stereo center right now? Yes, and it is going to be a tertiary carbocation, so we don't have to worry about rearrangement. So how many products are we going to have, Glenn? 2. It's a stereo center. So if it is a stereo center, you will have 2. If it's not a stereo center. So in this case, we are going to just draw our parent chain. And we are going to have one answer where we retain the stereochemistry. So this is going to be the OET on a wedge. And the methyl is still going to be on a dash. But then we're going to get one where we flip. And Mags, I think this is what you were talking about. What if we just flip like this? It doesn't matter which side we draw it on, just as long as we clearly distinguish that one is a wedge, one is a dash. So that's the only important thing. But in an SN1 reaction, when you have a stereo center, you're going to get a mixture of both, of retaining the stereo center and inverting it, a 50-50 mix. Okay? Both of those down? Okay. For our next one. This was one meant to trick you. You are going to have 2 answers. You're going to have this, and you are going to have this. Did you guys get those answers? Good. What was the trick here that they were trying to get you to fall for?
Like shifts.
Yep, they were trying to get you to fall for a shift. But remember, you only have a shift if it is directly adjacent to. In this case, you are 2 carbons away.
Dang.
So if you're 2 carbons away, you will not have that shift. You have to be adjacent to it. And it is a stereo center, so you're going to get 50-50 again, retaining 50% inversion. Morgan, you look a little perplexed.
So can you like show the, like, why is it a stereo center?
Yep.
Because like I only see like 3. Well,
I only got the one with the dash. I didn't get the solid wedge one.
Okay, so what's not drawn here?
the
I-
hydrogens.
Okay, there's just one coming out there, right? So we're going to call you number 1. This will be number 4 because hydrogen's always number 4, right? So
Yeah.
you go to a CH2 or you go to a CH2. Is there any difference?
No.
Okay, you go to another CH2. You go to a CH3, CH3. Is there a difference?
Yeah.
Yep, so this is going to be number 3. Sorry. This is going to be number 2. This is going to be number 3. It is an R. Because
Okay, now
remember,
I see it. I just forgot about the hydrogen.
so don't forget that hydrogen's there, but also don't forget, if you have a ring, see if there's a difference on the ring. And that will usually tell you if it's a stereo center or not. And there is, right? Because 2 carbons away, there are 2 methyls coming off only on one side. It's not on both sides. Okay,
When
question?
do you know when to use a dash and when to use a wedge?
What do you mean? Let me go back to the problem and then you can.
So if it wasn't a stereo center and you were just having one product,
Oh,
would a
you
wedge
don't-
or a dash?
You don't need to do that though. You only need to have stereo specificity when it's not.
Oh, okay.
So it's sorry, you only need stereo specificity when it is a stereo center. So those dashes and wedges only matter when it is a stereo center.
Okay, sounds good.
Otherwise, like here, right on this side,
They're just lines.
they're just lines. Yep. So you just do lines because it's not a stereo center.
Okay. That makes more sense.
All right. Next page. Show the major organic product or reactant in the following SN2 reactions. There are 7 answers required. Show stereochemistry where appropriate. So let's work through the first one. I'll give you guys 30 seconds, and then we will march on. All right. So we know that this is an SN2 reaction. So what do we just have to identify? The only thing we need to identify is our carbon, where our leaving group is. So this is my carbon with my leaving group. Is it a stereo center?
Maybe.
That's not an answer.
I think yes, but
It isn't. It is a stereo center because there are 4 different things. Just count everything that's there. What did you forget?
well, I knew the hydrogen was there, so I
So-
counted.
Hydrogen, iodine, CH3, and then long ass chain. Those are all different,
Okay.
right?
Yes.
Okay. I'm going to judge you a little bit on that one because you shouldn't make that mistake. Nothing personal. Okay. So now when I draw my chain, when I have my stereo center, do I get a 50-50 mix? Do I get one product? What happens in SN2?
Isn't it just one major product?
It's only one product. There's no major or minor with SN2. It is going to be inversion, right? So my stereo center, it was on the wedge. Now it is going to be dash. And that's because it's called a backside attack. All right. And any other stereo center I may have stays the same because I only affect the stereo center where I am attacking. So the other stereo center here, no chemistry is happening there. It just stays as is.
In this case, the triple bond of the
You can
carbon-
just write CN as the
Okay.
C triple bond at the end. That's the same thing. If you wanted to, you could write C triple bond to N. It's up to you. But CN is the shorthand way. Make sense?
Mhm.
Okay. There is about a minute and a half left, so I'm going to stop it right here, and then we'll come right back, and we'll continue on just that the 40 minutes is up. So I will come right back, and we will continue on with our wonderful lesson.